I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will see the introduction about constraint satisfaction problem and we'll solve one problem in this concept of CSP. And first, we'll see what is the necessity of studying constraint satisfaction problem. The constraint satisfaction problems, often called as CSPs. Studying constraint satisfaction problems helps develop efficient algorithms. CSPs are used in scheduling, resource allocation, and network optimization. They provide a framework for knowledge representation and problem solving in AI. CSPs are essential for understanding computational complexity and algorithm design. They have interdisciplinary connections to operations, research, cognitive science, and data sciences. We'll see the basic introduction about constraint satisfaction problem first. So, what is constraint satisfaction problem? The constraint satisfaction problem is a fundamental problem solving framework in artificial intelligence and optimization. It involves assigning values to a set of variables while ensuring that all given constraints are satisfied. And the CSPs are widely used in various domains such as AI, scheduling, cryptography, and optimization. The three key components of CSPs are variables of x-axis, which represents unknowns that need values. Say, for example, countries in a map coloring problem. Domains, we are representing it as DD, which specify the possible values of variables I can take, that is red, blue, and green for map coloring. And constraints often referred to as C, which define the restrictions on variable assignments. And that means example is or adjacent regions cannot have the same color. Some real world examples of CSPs include Sudoku, map coloring problems, and scheduling tasks, where efficient solutions are required to meet constraints effectively. And how to solve CSPs? How are CSPs or constraint satisfaction problems are solved? CSPs are solved using various search algorithms and interference techniques that ensure constraints are met while exploring possible solutions efficiently. Common methods include backtracking search, which assigns the values incrementally and backtracks upon constraint violations. For next, forward checking, which proactively eliminates inconsistent values from future choices to reduce the search space. Next, constrained propagation, which applies a logical interference to further restrict possible values and simply simplify the problem. These approaches make CSPs useful in real world applications such as artificial intelligence and robotics, where decision making is constrained by logical rules. And next, cryptography where secure key assignments follow strict mathematical constraints. Network security, in this case, where access control rules must be enforced. And logistics and scheduling, in this case, where optimal resource allocation and time management are essential for efficiency. Next, we'll see one example problem for CSP that is called a cryptographic algorithm. Sometimes we are calling it a script algorithm. This crypt algorithm is a mathematical process designed to secure data by converting readable information, that is the plain text, into a unreadable format, ciphertext through encryption, through the encryption process. This is what it is happening. The same or a different algorithm used to decrypt the ciphertext back into the original form, ensuring that only authorized users can access the data. These algorithms are crucial for data security in communication, online transaction, and information storage. And let us see some key features of cryptographic algorithms. First, encryption. Encryption is the process of converting plain text into ciphertext to maintain confidentiality. It ensures that even if unauthorized users access the data, they cannot understand its contents without the decryption key. And encryption algorithms such as AES, Advanced Encryption Standard, or RSA, are commonly used in secure communication and data storage. Next, decryption. The decryption is the reverse of encryption, where ciphertext is converted back into the plain text. Only authorized users with the correct decryption key can access the original data. This process ensures that the secure information can be transmitted safely and retrieved without being compromised. And what is the key usage used in this case? Cryptographic algorithms rely on encryption keys to control the transformation of data. In system symmetric cryptography, the same key is used for both encryption and decryption, while asymmetric cryptography uses a pair of public and private keys. The security of the algorithm depends on keeping these keys secret and managing them properly. Next, security. Cryptographic algorithms provide security by preventing unauthorized access, data manipulation, and cyber threats such as that is eavesdropping and hacking. Eavesdropping, and hacking. They ensure data integrity, confidentiality, and authenticity, making them essential for applications like online banking, digital signatures, and secure messaging. Next, we'll see some constrained problems in this case. Constraints in cryptography. We have to follow some. So this is the problem. We have taken on cryptographic problem. We have taken the example send plus more. We are getting the output it as money. Four-digit numbers. Four letters can be converted into five. That we'll see the problem in detail. First, we'll see the constraints. In the crypto algorithm, certain constraints must be followed to ensure valid and logical solutions. Each letter must be assigned a unique digit between 0 and 9, meaning no two letters can share the same numerical value. Additionally, one single digit number can be assigned to a letter, preventing the use of multi digit values. Next, logical assumptions can be made at the various levels during the solving process, but they must not contradict each other. To simplify the problem, it can be broken down into secured constraints, allowing for constraint satisfaction approach where different possibilities are explored systematically. Next, to find a valid solution, what we are doing it, various search techniques can be applied. If an assumption leads to an incorrect assignment, backtracking can be performed to revise previous choices and find the alternative path. Throughout the solving process, the fundamental rules of arithmetic must be strictly followed to ensure the correctness of the final solution. So the example what we have taken is send plus move and we are getting money. How we are going to assign the values that we'll see it in this problem. Send here if you are adding these two values, these two numbers, send. If you are adding a send plus more, we are getting money. And we here these four digit can be converted into five digit. One, two, three, four, and here one, two, three, four. It has been converted into money, and we have to find out the equivalent digit value zero between 0 to 9. The value should not be repeated for that is letters. Each letter should have the unique value. That is the main constraint. So in the first step, what we should understand is here we are getting one extra number called here it is a money. So yeah, if this money is obtained by, we are getting the carry over here. So here, what is this value here? M is available. So we are getting, suppose we'll be getting 1 0. We might have got it. So that only we are getting this M. This is the carry. The carry values will be assigned as C1, C2 and C3, and this is the C4. So here M is assigned to 1, so the same value will be repeated over here 1. So if you are adding which number, we are getting 1 0. If you are adding, first step is 9 plus 1. 9 plus 1, if we are adding, we are getting 1 0. So here already 1 is there, so we have to add 9. If we are adding 9, we are getting the value 1 0. So we are getting the value it as 0. So now the S should be assigned the value 9, M should be assigned the value 1, and here what is this? MO. The O is assigned with 0. O is assigned with 0. Three values we got it. Next step, in the second step, we'll move on to the value. We have to consider this, and if you are adding these two, we are getting the value n. So uh, if you are adding E plus, first the carry may be either 0 or 1 for this case. Let me consider first carry. This is the carry if I am considering 0 plus E plus O. And what is the O value? Equivalent value is 0. Here the 0 is there, is equal to what? N. So if the O if we are substituting 0, these two will be getting cancelled, but we are getting A is equal to N. Is it possible to get both the values are equal? It should not be the case. So we have to remove this. And the next step, if you are adding, instead of this carry 0, if you are adding the carry is equal to 1, E1, E plus here the O value. What is the equivalent O value? The numerical value is 0 is equal to N. So we are getting here this is cancelled. 1 plus E is equal to N. This we are considering equation number 1. This is the equation number 1. Next, we will move on to after getting this step, we should be moving on to the step n plus r. If you are adding n plus r, what you have to get? Here the carry may be either 0 or 1, C1, maybe or 0 or 1. So we have to write like this. So what we have written here, 9. 9 is assigned to this for this 1, 1, here 1, here 0. So O value is 0, M value is 1. So if you are adding these two, we are getting this. And in the previous equation is 1 plus E is equal to N. This is the equation number 1. And the next step is, what is the next step? We have to follow E plus O. If we are adding this, we are getting this only, we have got it 0 if we are substituting E is equal to N. So that is not possible because both the letters should have the same value. It should be different. Now we have to add the next step. We have to follow N plus third step, N plus R is equal to E. The carry may be either 0 or 1. So if I am substituting the carry is equal to 0, N plus R is equal to E. And I will be adding, because the carry surely will be there. So I have to add 1 plus 1 0. Why carry is being added? In order to get the 2-digit value, we have to add 1 0. And here 0, if you are considering carry as 0, you are getting N plus R is equal to E plus 10. This is the 10 is for the 2-digit value. Okay. So what is the n value here? What we can substitute? 1 plus E. N is equal to 1 plus E plus R is equal to E plus 10. So this E will be getting cancelled. So the R value is equal to 10 minus 1. 10 minus, what is the value we are getting? 10 minus 1. 10 minus 1 is what? 10 minus 1. So R is equal to 9. Is this value will be valid one? No, because already S is assigned the value as 9. So it is not possible. So 9 is already assigned to your this S. So the carry must be, here the carry must be 1. Carry must be 1. Now we have to write it as the next fourth step. Carry must be, we have to write it as what we have to write it as 1 plus, here we have substituted 0, so this is not possible. So now I am substituting 1 plus 1 plus 1 plus n plus r is equal to e plus 10. So what we have to substitute for then from the equation number 1, we will substitute 1 plus e plus r is equal to e plus 10. This e will be getting cancelled. 2 plus r is equal to 10. From this we will find out r is equal to 8. R is equal to, so r is equal to 8. Here there is no value of 8 is present. So where we have to write r? So here E will be there. This R we can write it as 8. There is no where the R is present. So we can keep R is equal to 8. So in this case, what is the value? 8. Or where the R is present, only one R is there. Right? Next. So it is, this is the possible value for R. Possible value. The same thing we have to repeat. So I'll be repeating over here 1, here 9. The 1 will be repeating 0. Next, where is R? And here the 9, 1, 0. Or we found out 8. Or we found out 8. So this is the possible value. Next, we have to consider D plus E is equal to Y. So here we have to consider D plus E is equal to Y. 2-digit should come. If you are adding 2-digit should come. So we will write it as a digit carry will be there now. C1, C2, C3 and C4. D 2-digit should come. D plus E is equal to Y plus 10 for obtaining the 2-digit value. So now there may be 2-digit value means we have to add other values. What is the value we have to add? Just we have to try it out. 5 plus 6, if I am adding, I will be getting 1, 1. This is the carry, no problem at all. D plus E if I am adding. But 1 it is not possible. Why 1 it is not possible? Already it is assigned, M is assigned to 1. So this we cannot take. Okay. And next, if I am adding 5 plus 7, I'll be getting 1 plus 2. So this may be possible. This may be because there is no 2 at all. And another value we can write it as 6 plus 7 is equal to 13. This is also possible. Next we will try it out. This is also possible. And why may be, so from this conclusion we are coming to the conclusion that y may be the value. There may be two values, either this 2 or this 3. Y value, y maybe we can assume maybe either 2 or 3. 2 or 3. So we have to find out. 7 is common. Here, both the cases, 7 is common. The 7 should come either E or D. That we have to check it out. So if we are substituting for E, so in this case, if we are substituting here 7, here, just I will verify. If you are substituting 7, already what is the value it is there? What is the value is there? Here O is equal to 0. If we are substituting 7, we are getting the value is equal to 8. 8 it is already we have found out for R. So here what is the value n? So this may not be the choice. Why it may not be the choice? 7 plus 0, if you are adding even one more carry, if you are adding, we are getting one more carry. If you are in here, one more carry, if you are adding, you are getting 8. This 8 is for n. Already 8 is present for R, so this may not be the choice. So we have to find out the alternative value for this. So 7 we cannot take. So where we have to put the 7? 7 we have to substitute somewhere, no? So the 7 is assigned to, we can assign the 7 to this D. Okay. 7 is assigned to D. Now we found out n value. We have to find out 7 value. We have to find out. So this here 7 plus 5. 7 plus 5, 7 we are finding out this 7 we found out for this. So automatically we are finding for E is E, we are assigning the value is equal to 7 plus 5. If you are adding, you are getting 12. So the 2 is possible. Where the another E is available, here I am going to substitute 5, and here the 0 value. And if you are adding these two, 1 plus 5, what is the value you are getting for n? 1 plus 5 is equal to, I'll write it in different color. 1 plus 5 is equal to 6. So now the value for the value for n is 6. Value for n is 6. Value for E is 5. Value for D is 7. And the value for E here, what is the value? 6. And here E value is 5. Yes, very good. Fantastic. And Y is equal to 2. So 1. 6 plus 1, 7. 7 plus 8, 15. 1, 5. 1 carry is remaining. 1 plus 5, 6. 9 plus 1, 0, 1, 0. So if you are adding these two values, you are surely getting the answer. Now we found out for all the values, we found out the value it as. What is the value we found out? Hmm? In this case, so yes, so if you are adding these two, all these values, if you are adding all these values, what you are going to get it for yes? So for yes, 9, M1, for E5, and O, 0, for N, 6, for R, 8, for D we found out to 7, 2. And here, if you are substituting these values, what is the value we have to substitute it for S? The S value is S9. Here 1, this 1, and here 1, 0. Next E value is 5, and here the O value is 0. Next N value is 6, R value is 8, and D value is, what is D value? 7, and here this value is 5. If you are adding these two, 7 plus 5, 12, 1 will be the carry, and here 15, we are getting 15, and 1 carry will be there. 1 plus 5, 6, and 1 plus 5, there is no carry at all. 9 plus 1, 1, 0. So if you are adding, these two values are getting. So this would be the final answer. Hope everyone understood this problem. So step by step, I'll go one more time. So I have taken the example send plus move. So first what, and if you are adding these two, we are getting MONEY money. And we have to put the box like this. First M, only one carry should be present. If you are adding 1, 0, here it will be coming it as 1, 0. If M value is 1, this M value transfer over here. So what value we have to add for getting 1, 0? 9 plus 1. So 9 plus 1, this is the first step we have to follow. Then we have to go for E plus O. E plus O is equal to N, and the carry may be present or may not be present. If you are not, if you are substituting 0, we are getting E is equal to N. That step is not possible. So we are assuming this carry value is equal to 1 plus E plus O value is 0 is equal to N. and if you are striking out 1 plus e is equal to n, and then the remaining values we have to parallelly substitute. So next step is n plus r is equal to e, and here also carry may be present or may not be present. First, we are substituting carry is equal to 0 plus n plus r is equal to e plus 10, because in order to get two-digit number, we have to add 10. And n plus r is equal to e plus 10. This is not the possible step. No, and if you are substituting 1, if you are substituting the value, it is equal to value is equal to 1. 1 plus e plus r is equal to e plus 10. If you are substituting 1 plus e plus r, what you are getting, why it is not possible means that you should understand. E, so r value is equal to 9. Already 9 is present for yes. So this step is not possible. We have to assume it as carry will be present. 1 plus e is equal to plus r is equal to e plus 10. If we are substituting, so we are getting only, that is r is equal to 9. We are getting, so this is not possible. Then we have to consider it as, we have to consider it 0, this step only. And we have to consider 1 plus n plus r is present. And 2 plus, here e will be getting cancelled. 2 plus r is equal to 10. So if we are bringing r 2 into this side, r is equal to 8. So we have marked over here. The next step is d plus e is equal to y. D plus e is equal to y plus 10 in order to get two-digit number. The y may be, we have to add two numbers and we have to check. 5 plus 6, if you are adding, we are getting 1, 1. But 1 is not possible because this 1 is already assigned to m. So this is not possible. Next, if you are adding 5 plus 2, we are getting 1, 1, 2. It may be possible. Similarly, 6 plus 7, if you are adding 1, 1, 3, you are getting, this may also be possible. We have to substitute and then we have to take the values. So what you have to do is, first the 7, the common number is there. The common number, if you are substituting, suppose if you are substituting for E, you are not getting this value. So what we are going to do is, this 7 we are going to take it for D, and then automatically we have to substitute to 5. So if you are adding these two, we are getting 2. So this combination only possible, 7 plus 5, this combination. So if you are going to substitute all the values, and whether our answer is correct or not, how you are going to find out? You have to add 7 plus 5 is equal to 12, and carry will be carrying over here. 1 plus 6 is 7, 7 plus 8. 7 plus 8 is equal to 5. And 5 plus 0, 6, 9 plus 1, 1, 0. So in this way, we have to find out the constraint satisfaction problem. Hope everyone understood this problem. This may be the final, this will be the final answer, and the characteristics for each characteristic values are assigned. Hope everyone understood this problem very clearly about sen plus mo is equal to minus money. Similarly, we can solve any type of problem if you understand the basic concepts.